Hello everyone. This marks the first video in the series that I'm going to be using to live record me creating a Markov model Monte Carlo simulation for the NBA basketball games. There are a few purposes while I'm doing this. The first is to remember myself how I did it when I am, a year after completing it, want to understand my code. The other is as a guide to others who are interested in also building the model, a tutorial for certain people on how to use certain R functions, and then finally a way for myself to learn how I used to do it in case I have to do it again, similar to the first purpose. So the question for this video is, what is a Markov model? And what is a Monte Carlo simulation for that Markov model? You see two quotes up on the screen, both conveniently provided by Wikipedia. Markov model is a stochastic model used to model randomly changing systems. What that means is just that in the world around you, you can look this up, you can look up the definition on, but basically in the world around you, everything has a current state, and it has future states in which it can go to. A very common example is it's sunny outside today. Tomorrow there's a 5% chance it will be raining, or a 95% chance it will be sunny again. So the idea is that you're in a current state and you can go to these future states, for example these, with certain probabilities attached. These can be shown in a matrix where it's the current state and the future possibilities. So for an NBA example, the current state could be a play in which one team, for example Philadelphia, scores a layup for 2 points. What are the possible future states? Well, we know one future state is not a rebound. Since they've scored, it is now the other team's ball. However, a future state could be a play in which the other team scores 3 points. A future state could be a scenario or a play in which the other team gets a turnover and Philadelphia gets the ball back again. So the idea is that every team will have proclivities and underlying probabilities of how they will change to a future state. And by doing this analysis, you're able to find out what those probabilities for those future states are, which is where the Monte Carlo simulation comes into play. Definition: class of computational algorithms that rely on repeated random sampling to obtain numerical results. This is quite simply saying we know the probabilities for the different changing states within the NBA system. Let's run 100 simulations and see what the matchup score would be between these two teams in a hypothetical situation, and if we are correct in our forecasts or incorrect. So this model is originally intended to be a very simple one, in which you just look at whether the team scored or did not score, whether it was a turnover, out of bounds, rebound, etc. However, there is possibility in the future to incorporate other more stricter parameters that will hopefully give more accurate forecast data, such as position on the court in which a player shot, the specific name of the player on the team, certain fatigue symptoms, how many days a team has been on the road, or if they've been at home, etc., etc. However, for the most simple example that I'm going to work through here, it's going to be quite simply the changing from one state, each state being a play, to the future state.